Yes. So the theme we have chosen is healthcare technical challenge, where we'll be solving the problem of drug discovery, where we'll be helping to accelerate the process. The main problem here is it takes around 10 to 15 years and it costs over 1 billion. And the core challenge here is the search space of possible molecule is astronomical and millions of potential candidates. So the and existing approaches fall short because of the classical ML. It's fast scalable but sacrifices chemical accuracy, and quantum computing can capture multi-molecular precision, but current hardware limits scalability. So the gap here is it slows discovery, increases cost, and delays life-saving medicines. So our solution is a hybrid pipeline that combines the speed of machine learning with precision of quantum computing to accelerate drug discovery. So our approach will be where we'll be using classical pruning, where we use RDKit descriptors and a light ML model to shortlist 10 to 13 candidates from an open library. Then quantum refinement for each candidate, and we'll be using GenAI and RAG to summarize prior literature, explain result, and suggest parameter tweaks, and agentic automation to orchestrate the pipeline with cloud. So this is our solution architecture, where we'll collect data, then extract molecular descriptor, assemble model evaluation, model deployment, then quantum optimization, lowest energy conformation, final rank drug candidates, and end user interaction. So the tech stack we'll be using is IBM Qiskit for quantum computing to run quantum chemistry simulations. For LLMs, we'll be using Granite or AWS Bedrock to generate molecular ideas. And for RAG, we'll connect with scientific data for realistic suggestion. And for cheminformatics, we'll be using RDKit for molecule preparation, visualization, and property calculation, and other tools. For cloud and DevOps, we'll be using AWS FreeTire for CI/CD pipeline orchestration, storage, and data prep. We'll also be using S3 Lambda and step function to manage experiment flow. And then, of course, the supporting tools. So the role of GenAI in the solution is the candidate generator. It creates new molecule structure based on input description or dataset. The knowledge booster, it uses scientific text or data to ensure molecules are realistic, and it filterizes and prioritizes the molecule that are likely to be useful for drug as a drug candidate. And at last, the explainer, it summarizes the result from quantum simulation in simple human readable language. So the uniqueness of our product is it's an hybrid multi-cloud approach where we'll be using AWS for data prep and IBM for quantum part. It's going to be a first of its kind low cost pipeline. Uh, for, we'll also be using quantum plus Gen AI, which uses Gen AI to guide molecule selection, and quantum layer explores chemical conformations. And it's a drug discovery focus, so it's tailored specifically for early stage molecule screening, unlike general quantum optimization demo that has this has direct pharma use case. And agentic orchestration, AI agents coordinate the workflow automatically. So the impact of this is it's cost saving, it has competitive advantage. Pharma giants like Novartis are already exploring quantum early adaptation, and then partnership and ecosystem growth. Cloud providers IBM, AWS reduce time to discovery. Classical drug discovery takes around 10 to 15 years. This cut short from 10 to 13 months approximately. And also the personalized medicine in the long term, quantum simulation can model individual specific drug interaction, paving the way for custom treatments. Yeah, thank you.